Silesian Phoenix from Silesian University of Technology. Since 2018, we are engaged in designing and developing robotic mobile platforms for rovers competitions. As far, we have designed two rovers, Phoenix 1 and Phoenix 2, that took part in European Rover Challenge with some minor successes. Currently, with the fresh squad, we are in development of our third platform, Phoenix 3. Right now, we have 25 members from different faculties and different fields of study. The team is divided into 5 sections responsible for the mechanic, electronic, software, science and marketing parts of the project. On a day-to-day basis, we have 2 rooms at our disposal. The first room is used for office work, software development and designing in CAX software. It is also the location of our team management. The second room is utilized as the workshop. If needed, we have access to University Technical. We use a parking lot and nearby lot for field tests.
Phoenix 3 platform is based on a classic rocker suspension. The rover's dimensions are 700mm in width, 910mm in length and 600mm in height. The overall mass of the platform is about 52 kilograms. The mobility system consists of 4 independent wheels. Each wheel has its own BLDC motor with an integrated planetary gearbox and steering assembly. The current setup is chosen based on the experiences and knowledge from the Phoenix 1 and Phoenix 2 platforms. We also try to keep all subsystems simple to reduce the possibility of default and increase reliability. The unique feature of our platform is that almost all structural components are made of carbon epoxy composite. It is unseen in the design of the Rover Challenge rovers.
As we are a fresh team, we decided to use an on-shelf components to reduce the risk of the failure during our first competition. Our power system uses voltage converters. Each power line is fuse protected, and every converter incorporates overcurrent, overvoltage, and temperature protection. From electronic components, we are using Odroid C4 SBC as our main computational unit. For stable work of servo motors in steering axis, we use Raspberry Pi Pico, which communicates with Odroid using TCP/IP protocol. The main drive is controlled by MAP Robotics BLDC drivers, which utilize the CAN bus for communication with the main computing unit. The used battery topology is 7S10P, which gives us a nominal voltage of 25.9 volts with a capacity of 22 amp hours. Depending on the current rover's mode, proper light indication is used. We also use an industrial-grade safety button that cuts off power to the mobility system in emergency situations.
To manipulate objects during the competition, we designed and built 5 degrees of freedom robotic arm. In our design, we incorporated stepper motors with planetary gearboxes, responsible for the movement of the arm. The end effector is modular and in standard mode we have access to 2 types of jaws, normal and precise. The arm is designed to meet the demands of the mission. The effective range is 1.1 meter and we can precisely manipulate the switchboard as well as lifting objects. For controlling the arm, we are using standard stepper controllers, which gave us precision and enough power for the whole manipulation system.
To test our scientific hypothesis, it is needed to acquire information about the traces in the source samples. For source samples collection, we are using a scoop that is mounted on the robotic arm's end effector. Collected samples are next deposited in the test tube attached to the rover for laboratory tests. We are measuring amount of phosphorus, nitrogen and potassium with an electrical sensor, and for nitrates we are using test strips. On top of that, we are measuring humidity, pH and electrical conductivity. We also use a set of semiconductor sensors for detecting methane and propane in the environment.
According to our experience, one of the most important tasks is to secure a strong and stable wireless connection between a base and the rover. So because of that, we decided to use industry-grade communication unit made by Moxa. To secure the monet range, we are using 2.4 MHz Wi-Fi bandwidth. The ground station is equipped with an omnidirectional antenna. 2 Xbox controllers are used for operating the platform, 1 for each operator. The used vision system consists of 360-degree camera to observe the field under the rover, a rotary camera for wide shots, and a stereoscopic camera for AI algorithms.
We hope to see you in July.
Woo!